Welcome to engineering chemistry class. In today's lesson, that is lesson 4, we are going to see metallic bonding. Let me start with the reflections part. Students, write what are the types of bonds you know and write some properties of metals. Let me explain the types of bonds. Yes, you might have written covalent bonding, ionic bonding, hydrogen bonding and metallic bonding also. Correct. As today's class is metallic bonding, we are going to discuss about only metallic bonding. Before explaining the metallic bonding, what are the properties of metals and why the metals show these properties? Let me explain in this lesson. What are the properties? Correct, you are correct. They are good electrical and thermal conductors. They are opaque. They have high refractive power. They have high melting and boiling points. They crystallize with high coordination number. They are ductile, malleable, luster, high density, etc. They can form alloys. They have high elasticity. They can withstand up to high stress and they can withstand up to high temperature also. Yes, you are right. So let me tell what is metallic bonding. The force that hold the atoms of pure metal together in a crystal as a result of attraction between positive ion and the freely moving delocalized electrons is known as metallic bonding. So there is an attractive force between positive ion and the freely mobile delocalized electrons is known as metallic bonding. So the properties you have written like electrical, thermal conductors, opaque, melting, boiling, ductile, malleable, etc. cannot be explained based on normal ionic or covalent bonding. So there are theories which explain all these properties. We are going to see what are the theories. First theory is free electron theory or electron hole theory or electron gas theory. According to this theory, each atom in a metal crystal loses all valence electrons. Thus, the electrons form an electron pool or electron gas in a crystal lattice. So, the resulting positively charged metal ions are called kernels, and the mobile electrons and these kernels held together by electron pool or electron gas. These kernels or positive metallic ions do not float randomly in the sea of electrons, but they have definite positions at measurable distances from each other in a crystal lattices. So I told why the metal exhibits optical property, electrical conductivity, thermal conductivity, etc. Because they possess free electrons. They have free electrons in the lattice. The optical property of metal, that is the lustrous nature, the silvery white, is due to the free electrons. So the free electrons are capable of observing all the wavelengths, then it is re-emitted. So the optical property is due to the presence of free electrons in a crystal lattice, and electrical conductivity is also due to the electrons that are being free to move in an electric field and thus conduct electricity through the metal. And coming to thermal conductivity, when the metal is heated, the electrons acquire kinetic energy. Thus, electron moves rapidly through the crystal and conduct heat to the other parts of the metal. And metals possess high tensile strength. They can result stretching without breaking due to the existence of strong electrostatic attraction between the kernels and the free mobile electrons. So they possess elastic property so that ions can change its position without breaking the metal crystal under stress and retain its original position on removing stress. Actually, electron C model is an assemblage of positive ions that are those are called as kernels immersed in a sea of mobile electrons, and each electron belongs to a number of positive ions and each positive ion belongs to a number of free electrons. So the force that binds between a metal atom and electrons within a sphere of influence is called as metallic bonding. Now you understand what is metallic bonding and the properties of metallic bonding, the properties of metal also. And coming to the next metallic bonding theory, that is valence bond theory, it is also nothing but resonance theory. According to this theory, metallic bonding is covalent in origin and metallic structure involves resonance of electron pair between each atom and its nearest neighbors. Consider any atom of metallic crystal. Here we take lithium as an example. It has covalent bonding with its neighboring atom by sharing an electron each. So lithium can form covalent bond with other lithium atom by sharing valence electron. The atom can form covalent bond to any of its neighboring lithium atom. So different arrangements are possible. Uh, but this bond is not permanently held between two atoms. Rather, it is continuously in resonance. Here, cohesive force holds the structure together. And another third theory is molecular orbital theory or band theory. See here, the molecular orbital theory of metallic crystal is similar like that of metallic orbital theory of covalent molecules. The electrons in metal are considered to belong to the crystal as a whole and not to individual or any pair of atoms. According to this theory, metallic bond result from delocalization of free electron orbitals over all the atoms of a metallic structure. When two atomic orbitals are combined, we will get two molecular orbitals. One of these is molecular or bonding molecular orbital and another one is anti-bonding molecular orbital. In general, number of atomic orbitals combine to form n by 2 bonding molecular orbital and n by 2 anti-bonding molecular orbitals. As the energy separates between the various molecular orbital is very small, they form energy bands. So these bands are separated from each other by an energy gap. So those bands are called as forbidden energy, forbidden gaps in which there are no electrons present. Let us see lithium crystal. The electronic configuration of lithium crystal is 1s2, 2s1, 2p0. If n atoms of lithium are allowed to combine to form lithium crystal, they will form three energy bands: 1s band, 2s band, and 2p band. The 1s band is completely filled, so it is a non-conducting band, and 2s band is valence band, since 2s band of each lithium atom contains one electron, and only bonding molecular orbitals are filled, which leaves empty upper band. The 2s and 2p bands are near in energy, so 2p band overlaps with 2s band. That is, this phenomenon is nothing but overlapping zones. And the electron bands where the electrons can move is nothing but permitted or Brazilian zones. What is Fermi level? The level below which all the energy levels are filled. Hope you all understand this theory of metallic bonding.